Okay, this is our last lesson for chapter 9. Woohoo! And we're going to talk about applications. So we're going to look at solving word problems again using systems of equations. And these might require us to use substitution or elimination. We're not going to do graphing with these, but these are very specific types of word problems. And we are going to use charts because we like to. Okay, so this first word problem, actually the first two are very similar. But this first one has to do with wind. Okay. So a jet can travel the 6,800-kilometer distance between New York and Paris in 6 hours, 48 minutes with the wind. That means that as the jet's going this way, that's big. As the jet's going this way, the wind is behind it. So the wind is kind of pushing it along a little bit. So that is what it means by with the wind. You know, it usually helps you. You're going a little bit faster because you're running with the wind. If you're running against the wind, or in this case, flying against the wind, you're going this way and the wind is pushing against you. So you have to work a little bit harder. Okay. So maybe you're going faster, but because the wind is pushing you, you're not really going as far. Okay. So in this case, it says the return trip against the same wind takes 8 hours. Find the rate of the jet in still air and the rate of the wind. So basically, what this is saying is if the jet's going the same speed in either direction, with the wind, he's going to be able to go a little bit faster, even though his jet's going the same speed. The wind is still pushing him. And when he's going against the wind, the jet's still going the same speed, okay, but it's pushing him back. So if you've ever ridden your bike on like a really windy day, you know how this works. If you're riding with the wind, you're pedaling, but you don't have to pedal as hard because the wind is pushing you. If you're going against the wind, you could be pedaling your little heart out and you're still not going as fast because the wind is pushing against you. Okay, so that's what it means to go with the wind or against the wind. Okay, so the speed of the jet in still air is what we're looking at. Okay. So, and then we're going to see how it affects the with the wind and without the wind. Okay, so with the wind, so the speed of the jet is r. That's what we're looking for. So we're looking for r. We want the rate of the jet. Okay, so the rate of the jet is r. So with the wind, he's going r plus w. Against the wind, it's r minus w. So w is the speed of the wind. So w equals the speed of the wind. Okay, or the rate of the wind. So when he's going with the wind, it's his speed plus the speed of the wind actually makes him go faster. And we know that that takes 6 hours and 48 minutes, which is actually 6.8. Okay, we're going to use 6.8 because 48 divided by 60 is 8/10. Okay, and we know that the distance is 6,800. When he's going against the wind, it's his speed minus the speed of the wind because the wind is going against him. We know that that takes 8 hours. And again, the same distance is 6,800. Okay, so here we have these two equations because it's rate times time equals distance. So let me write this out. We'll have 6.8 times r plus w equals 6,800. If I can write my eights. And here we have 8 times r minus w equals 6,800. Now, there's our system. The inclination is, well, let me distribute first. Don't distribute first. Watch what happens. So if I take this equation, I have 6.8 times this quantity. I'm going to take this quantity and I'm going to divide both sides. So I end up with r plus w equals 6,800 divided by 6.8 gives me 1,000. Okay, so dividing both sides by 6.8 gave me r plus w equals 1,000. Here I'm going to do the same thing, except I'm going to divide by 8. So I get r minus w, and 6,800 divided by 8 gives me 850. Well, look at this. I can just add it because those w's are going to disappear. And that's the trick with wind problems. You're going to end up with equations like this no matter what. Divide by whatever this is outside the parentheses, and then you have an easy elimination problem. So this is going to be 2r. These cancel out. I add these and I get 1850. Divide both sides by 2. R is equal to 925. Okay, so the speed of the jet is 925 kilometers per hour. That's in still air. That's if there's no wind at all. So the speed of the wind then, okay, they're not asking for the speed of the wind. Oh, yeah, they are. Then with the rate of the jet and still air and the rate of the wind. Okay. So I'm just going to use one of these, and I'm going to go ahead and use one of these. Let's use this one. I'm going to use the second one. So I have 8 times 925 minus W equals 6,800. And I chose that one because it didn't have a decimal. So 8 times 925 is 7,400 minus 8W equals 6,800. If I subtract 7,400 from both sides, I get this, minus 600, divide both sides by -8. And I get 75. So the speed of the wind, the rate of the wind, so we've got the jet is going 925 kilometers per hour, and the wind is going 75 kilometers per hour. So think about it. If it's 75 kilometers per hour, that's pretty strong wind. Um, if I'm adding them together, this is going about 1,000 kilometers per hour, okay, which is why we got the 6.8. This one is actually going only about 850 kilometers per hour, which is why it takes longer. Okay, it's called the relative speed. Okay, but the trick is you end up with equations like this. One of them is adding, one of them is subtracting. You end up with equations like this. You divide both sides by this number and you have an easy elimination. Okay, it works the exact same way with water current. Okay, you're either going upstream, which means you're fighting against the current, or you're going downstream and it's just carrying you along. Okay, so in a canoe race, a team paddles downstream 480 meters in 60 seconds. The same team makes the trip upstream in 80 seconds. So we're assuming that they're paddling at the same rate. It takes them longer to go upstream because the water current keeps kind of pushing them back down. It takes them less when they're going downstream because they're just flowing along with the current. Okay, so downstream is going to be R plus W, okay, because the current is carrying them, so they're going faster. Upstream, they're fighting against the current, and we're using W for water this time. So notice that we're setting these up, whether it's wind or water, we're setting up the exact same way. Okay, so it takes them downstream, it takes them 60 seconds. Upstream, it takes them 80 seconds. And the distance for both of them is 480 meters. Okay, so we're going to set these up the same way. 60 times R plus W equals 480. And 80 times R minus W equals 480. So if I divide this one both by 60, this is going to give me 80 because 480, I think, divided by 60 now is 8. My brain's going. This one's going to be R minus W equals 6, okay, because 480 divided by 80 equals 6. Okay, so this is pretty easy equation then. So I have 2R equals 14, so R equals 7. All right, and if I just plug it in, I'll just plug it in the first one. 60 times 7 plus W equals 480. So 60 times 7 is 420 plus 60W equals 480. So I have 60W equals 60. Look at that. W equals 1. So the rate of the canoers are paddling at 7 meters per second, and the water, this is canoe, is 1 meter per second. So in one case it's pushing, in the other case it's going against you. Okay, but we set these wind and the water current ones up the exact same way. And then we simplify our equations pretty quickly so that we have an easy elimination. Okay, here's a number puzzle. Ooh, I love these. The sum of two digits in a two-digit number is 12. Okay, a two-digit number. So you've got a number in the ones place, you've got a number in the tens place. Okay, so we're going to talk about this. This is going to be whatever's in the tens place, and this is going to be in the ones place. We call that the units place. Okay. The new number obtained when the digits are reversed is 36 more than the original number. Find the original number. Okay, so if I use T for my original number, T is what's in the tens place, U is what's in the units place. Okay, the value of that number, think of expanded form. So suppose I had 2 and a 5. The 2 is representative, because it's in the tens place, would be representative of 20. So 2 times 10. So what we're going to do then is we're going to say, well, 10 times whatever the digit in the tens place is, plus whatever the digit in the units place is. That's the value of that number. When I switch them, all I'm doing is switching the variables. So this becomes 10u plus t. Okay, so my original number, the value is 10t plus u, and my new number, the value is 10u plus t. Okay, so I'm going to use these to write my equation based on what they've given me up here. Okay, so it says the sum of two-digit and a two-digit number is 12. So I have t plus u equals 12. So there's one equation. Then it says the new number obtained, which these are the numbers. The digits are reversed, is 36 more than the original. So my new number is 10u plus t, and that's equal to 10t plus u plus 36, because the reverse number is 36 more. So these are my two equations. This one I can't use elimination, but I can use substitution. So I'm going to rewrite this as t is equal to 12 minus u. Okay, so I'm going to come over here and I'm going to substitute. Make sure I can keep this where you guys can see everything. All right, so I'm going to have 10u plus, for t I'm putting in 12 minus u. And that's equal to 10 times t is 12 minus u plus u plus 36. So all I did was take this equation and substitute 12 minus u for my t's. Okay, so there's 12 minus u, there's 12 minus u. So I'm going to simplify both sides. So this is going to give me 9u plus 12. This will be 120 minus 10u plus 36. So 9u plus 12 is equal to 120 plus 36 is 156. Negative 10u plus u is negative 9u. I'm going to add 9u to both sides, so that's going to give me 18u, and I'm going to subtract 12, so that's going to give me 144. So u is equal to 144 divided by 18 is 8. U is equal to 8. Whew. Okay, so then I'm going to plug in, I'm just going to plug it back into here. If u is 8, t has to be 4. Okay, so I have u is 8, and u is 8. U is 8 and t is 4. So that means my original number would have been 48. Okay, the t would have been 4 and the u would have been 8. So let's check it using this. So if my new number then would be 84, because all we're doing is reversing. So is 84 48 plus 36? Well, 48 plus 36 is 84. Yep. So the question was, find the original number. So the original number was 48. Okay. All right, here's an age puzzle. Okay, Mimi is 4 years older than Ronald. Okay, 5 years ago, she was twice as old as he was. Find their ages now. So we're going to call Mimi, we're going to call her M, and we're going to call Ronald R. 5 years ago, Mimi was M minus 5, and 5 years ago, Ronald was R minus 5. So we're going to write our two equations. Mimi is 4 years older than Ronald. So Ronald plus 4, because we're based on what he is now. 5 years ago, okay, so M minus 5, she was twice as old as he was. Well, he was R minus 5 at the time. So those are my two equations. So we already have that M is equal to R plus 4. So I'm going to, what? I think I'm just going to plug it in. I'm going to put these both in standard form. That's what I'm going to do. So this would be M minus 5 equals 2R minus 10. So I have M minus 2R equals 5. I added 5 to both sides. And this one would be M minus R equals 4. So let's look. I have M minus R equals 4. And I have M minus 2R equals 5. I'm just going to go through and I'm going to change these signs. And I'm going to add together. So the m's cancel. I'll have minus R equals 1. So R is equal to, that doesn't work. And that one doesn't work. Okay, I found my mistake. This should be a negative. Negative 10 plus 5 is negative 5. See, it's these signs. They get me every time. So this would be negative r equals -9. So r is equal to +9. That makes a little bit more sense. So Ronald, I'm going to call him Roger. Ronald is 9. So if Ronald is 9, then Mimi would be 13. Okay, so let's check to see if this works. So Mimi is 4 years older than Ronald. So if she's 13 and he's 9, there's a 4-year difference. 5 years ago, she would have been 8 and he would have been 4. So she would have been twice as old as he was. So that makes sense. So Mimi is currently 13 years old. And Ronald, who names their kid Ronald, is I'm nothing against that name. It's a lovely name. 9 years old. Okay. All right, so let's look at try this. A plane can fly 3,750 kilometers in 3 hours with the wind. So with the wind, it takes 3 hours, 3,750, and we're going to say R plus W. The plane takes 5 hours to travel the same distance against the wind, R minus W. So we're going to have find the rate of the plane in still air and the speed of the wind. Okay, so I have 3 times R plus W equals 3750, which is going to give me R plus W equals 3750 divided by 3 is 1250. And here I have 5 times R minus W equals 3750. So R minus W equals 3750 divided by 5 is 750. If I add these two together, I get 2R equals 2,000. So R equals 1,000. Okay. So if R is 1,000, I would have, let's do this one, 3 times 1,000 plus W equals 3,750. 3,000 plus 3W is 3,750. 3W equals 750. So W equals 250. So I have that I've got the rate of the plane is 1,000 kilometers per hour. The rate of the wind is 250 kilometers per hour. That's pretty fast. So let's double check. If we add these two together, I get 1,250, and if I multiply that times 3, it gives me 3,750. If I take 1,000 and I subtract 250, it gives me 750 times 5 is 3,750. So the plane is 1,000 kilometers per hour, and the wind is 250 kilometers per hour. Okay, which makes sense. If you're a couple miles up, the wind is pretty strong. Okay, and that is it for chapter 9, using systems of equations to solve problems.